Welcome, soil conservation and management students, for our video lecture series on soil resilience based on session 13 or chapter 16 of the textbook used for the course at the Royal University of Agriculture. In this video lecture number 3, we're going to focus on soil resilience factors, soil resiliency factors. Okay? And you can see here some of the things that we've talked about in video lecture number 1 and video lecture number 2. And we'll continue to talk about some soil processes and on soil resilience in our subsequent lecture as well. But let me introduce myself. I am Dr. Jared Williams with Brigham Young University, Idaho, in the United States of America. And this lecture was originally recorded for students at the Royal University of Agriculture in Phnom Penh, Cambodia. Let's begin our discussion here by talking about soil resilience factors. What are some of the factors? And these soil resiliency factors are really kind of tied closely to some of the things you talked about in soil science. Okay? And these include our 5 soil forming factors. Which are listed here, and then our 4 processes of soil formation. Now these make sense because what we've talked about in previous lectures is that the soil's resilience, or its ability to bounce back, to recover, really has to do with soil depth and the ability for new soil to be made. Okay, so as soil can be created, then we can have the soil can recover more quickly. And so it would make sense that soil forming factors and processes, so soil forming factors and soil forming processes, are going to influence the rate of resilience. Okay, so we also talked about the depth of soil. So if we've got soil factors that are contributing to deeper soils, in other words, we have, so the factors and the processes are, we have more additions than we have removals, then that's a good thing. The soil, that suggests the soil is resilient. But if our removal is greater than our addition, because our factors can't support it, then we'll have less soil resilience and need for intervention or management that will improve that. Okay, so the first one we're going to start in this lecture, we're going to focus in on these over here, our factors. In the next lecture, video lecture, we'll talk about processes, and actually we'll also, time will be discussed in the next lecture as well. It is part of our factors, but for length purposes, we're going to discuss it in the next video lecture. So let's start off by talking about parent material as a resilience factor. And really, when it comes to parent material, there is some truth that the types of parent material, such as organic materials, okay, will tend to build up more soil resilience. But really, the component of parent material that's most important is soil texture. So parent materials typically help determine what type of soil texture occurs. And so really, when it comes to parent material, we're really talking about soil texture, okay, and the influence of soil texture on soil resilience. So some of the things that soil texture is going to influence are movement of water, air, and heat, okay, total pore space, aggregate stability, surface crusting, and soil erosion. Obviously, soil textures that reduce the amount of soil erosion and surface crusting are likely to improve soil resilience. Soils that have a texture that allows for water and air to move out of the soil, in other words, faster percolation and infiltration rates, will tend to have less erosion and tend to be more resilient and recover quickly. Okay, and as well as any of these soil texture properties that influence soil organic matter. Factors that influence soil organic matter tend to help increase or maintain soil organic matter will also increase soil resilience. Okay, next let's talk about climate and the influence of climate on soil resilience. And we hinted to some of this earlier when we talked about dry and arid versus, versus wet and tropical climates. And I said in general, soils that come from arid regions are going to have low soil resilience, and those that come from from wet or tropical climates tend to have higher resilience. Now again, those are in general. We can always have differences. And the reason is precipitation and temperature, okay, greatly influence physical, chemical, and biological processes. In other words, when we have wetter and warmer climates, soil formation occurs more rapidly. And you can see that from this point down here, right? Weathering and transport of fine particles in soil formation. So new soil can form much more rapidly in tropical areas or areas that have more moisture and temperature. Whereas soils that are dry and have cooler or warmer temperatures, because the lack of water doesn't allow those physical and chemical and biological processes to be rapid. They're very slow processes, and so new soil is formed at a very slow rate. Okay? As well as the temperature and water, of course, greatly influence microbial processes. Another example is in a tropical area, you're going to have lush vegetation, a lot of plants growing, and so that has the ability to add organic matter back to the soil. Whereas in dry, arid regions, we have much less organic matter and vegetation, and so less organic matter being contributed back into the soil. Okay. The next one we have here, and I need to move my pretty picture, is Biota Flora, and we talked about this one in the previous slide, right? Vegetation, right, will definitely increase organic matter as we've listed down here. But soils that have much more vegetation, as we see over here, right, that vegetation, of course, protects the soil, okay, and allows organic matter to build up, improves soil aggregate stability. These are all soil chemical and physical and properties that help increase soil resilience. Okay? They help build soil, they help increase organic matter. And so, additionally, vegetation and microbial activity promote nutrient cycling. And when we start cycling our nutrients, we have more biomass, more plants can grow, and further increase the organic matter, the aggregate stability, the protection of the soil. Okay? So definitely biota and flora have an influence on this. Okay. Another example here is what about the fauna, the animals, the worms, right, the grubs, the beetles, the different animals that live within the soil, and really whether they're micro, meso, or macro fauna meaning animal, okay, they contribute to soil resilience in similar ways, right? They're helping to improve nutrient cycling, soil organic matter, and that of course all adds to soil aggregation. So a soil with a healthy microbial, which is your microbes, right? Your microcell, your meso, your small organisms like nematodes and worms, and our larger macroorganisms, they'll help to improve soil, make that soil healthier and more resilient. That can recover quicker because of the increased organic matter and the thickness that it creates, right? It makes the soil thicker. And so, again, some examples written here of what earthworms, termites, and ants do to improve structure. They mix that organic matter in. Microbes help in that nutrient cycling, which then creates more organic materials, more vegetation, okay, which increases the resilience of the soil. And that is resilience from degradation. Okay, the next here is anthropogenic. Now remember, we defined anthropogenic activities as activities. Let me get my pen here, that are human caused. Human caused. And so they are really the #1 cause of soil degradation today. Things like deforestation, intensive tillage, overgrazing, mining activities, GRI. And so these are major concerns. And soils, as mentioned earlier, aren't naturally designed to be resilient against these types of degradation. These types of deforestation, anthropogenic activities, soils just haven't built a natural resistance to them. Okay? And so they do definitely, these disturbances, these do cause degradation. Now, as far as things like intensive tillage, for example, we can manage that through improved soil tillage, right? Improved management. We can use no-till or conservation tillage that can help rebound, help the soil bounce back. Okay. As well as government policies, right? There can be government policies to help protect land and to educate farmers and landowners on how they can manage their lands in order to reduce the impact of anthropogenic activities on soils. That can encourage practices that will increase soil resilience. In other words, the ability for the soil to bounce back or recover from these disturbances. Okay. The final component we want to talk about as part of this lecture video number 3 is topographic features, or topography, okay, and the effect of topography on soil resilience. And we've got 4 different points on topography. We have elevation, slope length, slope steepness, and landscape position. And so when we look at elevation, areas with low elevation, like Phnom Penh, for example, tend to have accumulated eroded soil material and tend to have a higher soil resilience. Soils at high elevations, mountains, for example, tend to be more eroded and have thinner topsoils and therefore have lower soil resilience. Okay. Slope length. If we have a short length, short versus long, okay, lengths, then with a short length there's less erosion happening, higher infiltration rates, and so we're going to see a higher resilience in these soils. Whereas long slopes allow for more erosion, lower infiltration rates, and low soil resilience. Similar with soil steepness, right? If it's very steep, jiao tang, if it's such, then it will have less vegetation on it, definitely higher erosivity, thinner topsoil, and lower infiltration rates, meaning that it has very low soil resilience. And if you think about soils on steep slopes, they typically do not, if the vegetation is removed, they do not recover. They normally erode away and don't recover. Whereas if we're on flat, okay, if it is flat or horizontal, not steep, okay, then we have higher infiltration rates. Soil particles they have eroded from high places accumulate, and we have high soil resilience. Okay. What about landscape position? Well, things like the summit or shoulder, okay, are going to have low resilience because they have high erosivity. They do not accumulate soil because they're at the top, right? They typically have a little less vegetation and fauna and thin topsoil. So the soil resilience of soils on shoulder and summit positions is poor. Foot and toe slope positions is high because this is where soil accumulates when it erodes. And you can't see that because my picture is in the way. Let me move that away and move it up here. And so these areas have high accumulation, high soil infiltration rates. So these landscape positions tend to have high soil resilience. This concludes our video lecture number 3 on soil resilience factors, and we're mostly focused on parent material, biota, topography, and climate.